All right, we need to build a cylindrical can that holds 1 liter. What dimensions will minimize the amount of metal needed to make the can? And note here, 1 liter is 1,000 cubic centimeters. All right, so we need to look at a can and figure out what its surface area is. So if you've got a cylindrical can, it's going to look like this. So its surface area, I'm just going to call that A. Its surface area is, that's the thing we want to minimize because that tells how much material we need. The surface area is going to be 2 times pi r squared, because that gets you the top and the bottom, which are both circles. And to get the this part of the can, the outside, that's going to be 2 pi r. 2 pi r gets you the circumference, and h is the height of the thing. So this is the top and bottom, and this is the side. So that's the thing we need to minimize. And right now it's a function of 2 variables, r and h. So this right here says that it needs to hold 1 liter. So we can use that to get rid of r or h. So the volume is 1 liter. 1 liter, so that's 1,000 cubic centimeters. And the volume of this thing is pi r squared h. You get that from the base is pi r squared, and then the length, the height of the thing is h. So pi r squared h gives you the volume. So what we need to do is take this and substitute it in to here. Now we could do it for r or h. H is going to be easier. So if you take this and solve for h, you get h is equal to 1,000 over 2 pi r squared. So I'm going to take that and plug it into here. You get the surface area is 2 pi r squared plus 2 pi r h, but the h is getting replaced with 1,000 over pi r squared. So let's see, what's this give us? 2 pi r squared plus, let's see, over here the pi's cancel. This cancels with one of those r's. And we're left with 2,000 on top and a single r on the bottom. So that's my area function, and that's the thing that I need to take the derivative of and set it equal to 0. So a prime is going to be 4 pi r, and then this is going to become minus 2,000 over r squared. You could do this as 2,000 r to the minus 1, and when you take the derivative you get minus 2,000 times r to the minus 2. All right, so we got to set that equal to 0 and solve. So if I set that equal to 0, let's see, I'm going to come over here and finish. I get 4 pi r equals 2,000 over r squared. So then let's see, if I move my r's over here, I get r cubed equals 2,000 over 4 pi. So that's 500 over pi. So 500 over pi is my r cubed. R is the cube root, this is an ugly number, of 500 over pi. Now let's just work out what that is on the calculator. This is an applied problem, so a decimal approximation is probably what we want. 500 divided by pi gives me 159 point something. I'm going to raise that to the 1/3 power. And I get 5.419. I'm going to round that to 5.42. And I'm going to make that a squiggly equal because I'm rounding. Okay, we should make sure that that's a minimum. And we could do that by doing the little chart. But I've done several of these. I'm getting kind of lazy. Let's use Desmos here. My original function was a equals 2 pi r squared. Let's see, Desmos will take r as a variable, plus 2,000 over r. Let's see if we get a minimum at, what we say r was. Will we get 5.42? Well, okay, this is not very helpful looking at it. Why is that? Well, it's because our volume is, if you look at the function here, our volume is supposed to be, well, our surface area is big compared to the other. What I want to do is I'm going to zoom in. On Desmos, if you press Shift and zoom, you can zoom in on a single axis. So I'm going to do that and zoom in on the x-axis here. And so this is saying, yeah, right here, 5.419. That's the number we were looking for. And 553.581. So sure enough, this is a minimum. So let's go back and make sure we answer the question. What dimensions will minimize the amount of metal needed to make the can? So R is going to be 5.42. What about H? Well, we've got to go back and use this to come up with what H is. R is going to be about 5.42. Now, I'm going to leave that number with all of its decimal places in my calculator. I'm going to use all of them when I come up with my H. H is going to be approximately, let's see, I'm going to square that, multiply it by pi, take its reciprocal, then multiply by 1,000. That gives me a H of 10.84. And R, I'm just going to recopy it here, 5.42 centimeters. All right. So that was pretty long. I think that's good enough for this video. We'll do the next example in the next one.